All right, so it looks like we are all good. And the other person who was here just left. All right. So today for Tech Tuesday, I'm going to be talking about an introduction to 3D printing. So we're just going to go over the basics of how a 3D printer works, how to find a 3D model, and how to print it out. And then finally, we're going to talk about common issues you might have while you are 3D printing whatever file you have. So this presentation is going to be focused a bit on 3D printing at home or by yourself. If you do want to 3D print through the library, most of this stuff we will be able to do for you, so you don't need to worry about that. But this is just sort of to have a better understanding of 3D printing. All right. So first, we do have a quick instructional video that goes over the basics of 3D printing. So we'll just go ahead and let me know if you can't hear it. You should be able to. Lovely. All right. It's muted. Cool. Can I? Share sound. That sounds like, all right, let's try that. Is that better?
Hey guys, it's Camry. Our school just got some 3D printers and Nat Geo let me borrow one to figure out how they work. But to be honest, I've just been using it to print tiny cats. It's like a tiny printed cat army. Cute, but no idea how I made them. These printers look super complicated. You know what? I'll just print an expert to help me out.
Hey Camry, I'm Cody Goldhahn, mechanical engineer and Nat Geo expert.
Wow, that thing really works.
What?
Nothing. So, Cody, can you tell me how a 3D printer shapes things so perfectly? Is it like a robot sculptor?
Not exactly. A person who sculpts stone removes chunks of a stone until it's in the desired shape. That's called a subtractive process. A 3D printer does the reverse. It's called an additive process. This means that the printer starts with nothing and then adds just enough material to make the same shape as a sculptor. It wastes less material than traditional manufacturing.
It looks like it's icing a cake.
Yep, it's just like a whole bunch of icing layers on a cake. A really hot extruder nozzle squeezes out liquid plastic, layer by layer, right up to where the computer program tells it to. Once the layer is done, the extruder raises up just enough for that next layer to get squeezed out on top.
Can a 3D printer print with other stuff?
Oh yeah, you can print with plastic, ceramics, glass, metal. Some scientists have even found a way to print with biological tissue.
Wow, kind of like how I printed you.
What?
Nothing.
The possibilities of 3D printers are endless. There's many different shapes and sizes of 3D printers. They can print houses, dental implants, complex bridges, even pizza.
Printable pizza, that's so cool. So how does the printer know how to print the exact shape of my cat toy?
Think about you and your computer as the toy designer. You draw a blueprint of anything you can imagine with your computer, creating a digital model. The computer then looks at your digital model, slices it up into layers, just like icing on the cake. Once it knows right where to put the icing, it tells the printer to squeeze out on that exact spot until the whole model is built just like your blueprints.
Wow, thanks so much for your help, Cody. You truly are one of a kind.
Hi Camry, I'm Cody Goldhahn, mechanical engineer. How can I help you?
I didn't know you had a twin.
Now that you know how that works, catch up on all the other episodes of How Things Work by clicking right here. And also make sure you subscribe to Nat Geo Kids by clicking down here. See you next time. Bye.
All right, so that was just a quick overview on how a 3D printer works. So now we're going to go into some of the intricacies of 3D printing and what you need to consider when you're choosing a 3D model. Nope, that's not what I wanted to do. There we go. So first I'm going to talk about some shapes that might be a little bit difficult to print. So for example, these Wolverine claws right here. The issue that I see with these prints is that they don't touch the print bed, the surface that the 3D print rests on. They don't have a lot of contact with that. So specifically in the points of the claws, and then right over here where the grip is. And so there are a couple ways that you can get around this. Just like this model over here, you can turn it around on its side so you can have more surface contact with the print bed. Or you can flip it around on this side. So this side is flat, but that does have a few concerns with printing vertically. But there's one way that we can get around sort of having not enough contact with the print bed, and that is with skirts, brims, and rafts. So a skirt isn't necessarily about securing contact to the print bed. The skirt is there to basically run out the filament, so you can make sure the filament is properly heated and it's the proper consistency before you get started on your actual print. And that can help your final print turn out much better. But with the brims and rafts, those will help secure our print to the print bed. The brim is very similar to the skirt, except it goes all the way up to the edge of the print and secures itself to the print. So it creates a larger area for the print to anchor itself to and makes it much easier to print. Then the raft is just a platform basically for your print to rest on. So that would be one way that you can print sort of a difficult print like that, is you make a raft or a brim around these points, and that would help secure them so your print doesn't move around as you're printing. Excuse me. Another tough shape to print would be this TRex shape or this TRex model. So there's a couple issues with this TRex model. Primarily, it's very intricate and detailed. So if you look, there's just all these little spikes, very smooth and round. It can be very difficult to very accurately capture that with a low quality 3D printer. So if you have more of a budget model, you might want to consider finding a different file or like choosing a different file in general. The other thing that you might notice is that because the printer goes from the bottom up, we don't need to worry about the print sticking to the print bed because we have this rock thing at the bottom. But what we do need to be concerned about is all these floating parts. So this head, the neck, the rib cage, the tail especially, they're not connected to where the print bed would be. So the printer wouldn't be able to print those properly. And so you can try to rotate things around to try and get it flush against the print bed, but you'll still have a few issues with like this leg here or this arm if you print it on one side. So the way we get around that is with something called supports. So supports are pieces of plastic that are printed out from the print bed, and they're built up to support the parts of the print that would arch over and wouldn't be able to be printed normally. So you can see with these funnel shapes, there is the inner cylinder and then the funnel that reaches outward. Now, normally the funnel part, we wouldn't be able to print that, but the supports create a surface that the filament can latch onto as it's printing. And so we could also do that over here by creating branches of filament, by creating pillars of filament that could latch onto key areas of this print, and it will make it much easier to print out. Finally, we can talk about the strengths of 3D prints. The strength of a 3D print is determined by the interior of it mostly. So all 3D prints have an interior called infill, and you can sort of see the different kinds of infill here. Here we have 10% infill, and those are some pretty wide hexagons that you can probably like stick a finger into. This isn't going to be particularly strong and would break under duress. This middle one, this 30% infill, is you can see that the hexagons are much smaller, so it would be a lot more durable than the 10%. And then we have 50% filament, which is probably the highest you would want to go, because beyond that, it might get a bit redundant. But this has a lot of filament. You can see half of the interior is made up of this crisscross of filament. And so the common or the universal filament percentage is usually around 20%. That generally makes these prints usable for daily wear. So for something like this little, I don't know how well you can see that, this little Jigglypuff guy, he's just going to be an ornament, a decoration, and he's pretty small. So you could honestly get away with 5 or even 0% infill with a little ornament like this. But something that you would use very often, like a tool holder, you would want a bit more filament because it'll be holding more weight and it'd be useful. So for something like, I make a lot of props with my 3D printer. And so I usually hover around the 10 to 15 range just to give them some strength, but to not make them too heavy, because that's the balance between infill, having too little and having too much. You want enough infill to make it strong, but you don't want too much infill to make it heavy and expensive. All right, so unlike regular printing, where you can just find a picture online and send it to your printer, with 3D printing, you need a special model. So you need a 3D digital model, and those can be pretty hard to find. But I have a couple of suggestions on how you can get your hands on something to print. For example, the number one resource that I and pretty much anyone would recommend is called Thingiverse.com. Just Thingiverse. And the benefit of Thingiverse.com is that it has a large selection of 3D models that are all completely free. Now, the quality can vary, but generally, if you're just looking to print something out and you don't really care what it is, they're definitely the go-to. They have so many fun and cool little models. For example, this dinosaur model, this T-Rex model, was from Thingiverse.com. Same with these Wolverine claws. So there's a whole bunch of different models that you can find on their website. And again, it's free. So it's a great place to start. Now, if you want something in particular, you might not be able to find it on Thingiverse. They do have a wide selection, but if you are a bit more picky, then you might want to try Etsy. Now, the downside of Etsy is that it is a shopping platform. So you need to purchase the 3D prints. And the real downside about that is that if you're spending your own money, if you don't like the product, unfortunately on Etsy, digital returns are not accepted because it's a digital file and you can very easily keep it even though you return it, unlike a regular file. So if you purchase a 3D model and you don't like it, unfortunately you can't return it. Ask me how I know. So yeah, I've been burned a couple of times, but I've also gotten some great prints on that site. So do your research as on any site and know what you're looking for. Finally, if you want something super specific, whether that's personalized or just something that doesn't really exist yet, then Tinkercad is a website that you can make your own prints. Now, there are softwares that can do a lot more technical things like Blender, but Tinkercad is free, it's in your browser, and it's surprisingly powerful for being free. They have a whole host of things that you like models that you can download right from their site, made with their shapes. So if you're looking for something very specific, go to Tinkercad. So now you have your 3D model. Unfortunately, you can't print it yet. You need to use what's called a slicer software. So a slicer software basically turns your solid 3D model into the individual layers of icing, like I talked about in the video I showed you. So the most common one, the one that I personally use and the one the library uses, is called Cura. It's generally accepted and it has a whole host of uses. But there are other slicers if you don't want to use Cura, for example, or you just want to try something new. We have this slicer with an E instead of the E, or with the 3 instead of the E because we're cool. And then Simplify 3D is another slicer software. For the purposes of this program, I'm going to be using Cura because that's what I have. So with Cura, you start with the open work plane. You can drag and drop your file into that work plane. So here I have just like a phone stand that I thought was pretty cool. And you can adjust how the software slices your model along this menu on the right-hand side. So you can see I underline the aspects that we talked about. So the infill is automatically set to 20%. Because this print doesn't have a lot of width, I would feel comfortable bringing that down to 10%. But probably not past that because I do want it to be relatively sturdy. And this little curved part here, I feel would be prone to breaking. So I do want strength in there. And then I would want to generate support. So the thing about Cura is it will tell you if a 3D printer might have issues printing out a certain part of your print. And you can tell, you can tell this with this red with these red markings here and a little bit here. And though you can't see it, it's probably going to be on this underside here. And so that tells me that I definitely want to use supports. Now, there is a couple of different kinds of supports. My preference is tree supports, which are basically those pillars of plastic that just attach to a single point. But there's also supports like this that basically, I don't know how easy it is to see, but it is like all around the print. And so it connects in multiple places. So it's a sturdier support, but it can be much harder to take off in the end. So I prefer tree supports because they're easier to take off. But if you prefer a better support, then I would avoid tree supports. Then once you have everything done, and then right below the support menu, wasn't able to capture everything in one screenshot, unfortunately. But right below the support is where you can choose to add a skirt, a brim, or a raft. Now for my print, I would choose just a skirt because this base right here looks plenty sturdy enough that I don't need to worry about it adhering to the print bed itself. All right, and then once you have all your information properly selected, most of the time you can just leave it as is. then you'd go over to the slice button, and that'll tell you about how long, about how much it'll weigh, and about what length of filament you would need. So, pardon me. So this can give you an idea of how much it would cost in the makerspace. We can give you just an estimate of that. However, if you're doing it yourself, then you don't need to really worry about the cost you don't have to worry about the weight. You can just worry about the length of filament. So now, troubleshooting some issues with 3D printing. 3D printing is complicated. There's a lot of things that can go wrong because these machines can be super technical and difficult. So I'm just going to go over two of the most common issues that I personally run into and how I typically fix them. So the first issue is that the print will not stick to the bed. And when that happens, you get sort of a chunky mess like that. So there are a couple reasons why this might be the case, why this might be occurring, and each one has a slightly different way to fix it. So the most common reason why the print might not stick to the bed is that the print bed itself is not level. Generally, before each print, you want to make sure that the print bed is level so the print adheres properly. Each 3D printer levels itself differently. Some, like our 3D printers, can do it pretty much automatically, whereas mine at home requires a lot of manual work. But if you make sure that the print bed is level and it's still not sticking properly, then you might want to check the print bed temperature. That if the print bed is too cold, then the filament won't adhere properly to the print bed. And if you fix the print bed, make sure the bed is the right temperature and it's still not working, it might just be that your print bed is too slick. And so you can try using a sticky substance. A lot of people swear by Elmer's glue sticks. That's what we use here at the library. But you do have to wash it after every use, wash the glue off after every use, or your print bed becomes really crusty and kind of gross. Now, if you have a removable print bed, that can be a perfectly fine option. At my house, I don't have that, so I use painter's tape. I've also heard good things about using hairspray as a adhesive. However, there is one last suggestion. If you have been 3D printing for a while and you know that this is something you want to invest into, there are things called printer bed covers, just right here, that are basically like plates of plastic that you can put onto your print bed and they'll create a better adhesive surface. You can find these on like Amazon for $20 maybe, less than a roll of filament. But they can also be quite expensive. And this just creates a better surface for your prints to stick to if your print bed is made out of like glass or something. Finally, stringy print. So you see all these little bits of filament right over here and over here. It's making the cube look a little bit icky. So again, the first thing you want to think about is the temperature of the filament. If it's too hot or too cold, if it's too hot, it'll get a little bit too runny. And so you can get the strings here. And if it's too cold, it won't extrude properly. So you can get some little bits and bobs and globs that way. So make sure that the filament or the temperature is coded to the filament that you are using. You can also try turning down the printer speed. So if the printer is going too fast, it can just be leaving little wispies of filament that way. You can also just make sure that the nozzle itself is clean. If there's little bits stuck to the nozzle itself, that can linger on the prints themselves and cause these issues. So with both of these prints or with both of these issues, if you've done all the troubleshooting you can, and you still can't figure out what's wrong, try printing out a different file. Like a calibration cube is really common to use. And if you get the same issues with that calibration cube, you know that the issue is in fact with your printer and you can continue troubleshooting. However, if the second file, if that calibration cube prints out fine, then you know that it might be an issue with the file and you can look for either a new file or you can look for just try and adjust the file that you have. Whoopsies. All right, so again, this was more of a look into 3D printing yourself at home. If you do want to 3D print something and you do not have your own 3D printer, you can come to the Aurora Library Makerspace and join us there. We'll be able to help you. The Makerspace is currently open by appointment only. You can make an appointment at aurorapubliclibrary.makerspace. Let me just go ahead and I can go ahead and put that in the chats for you guys. If you feel so inclined. Or you can call 630-264-4117. And again, we'll be doing most of the effort in 3D printing. You just need to bring us a file. But other than that, that is my presentation. If there's any questions, I can go ahead and answer that. Otherwise, I can just run through the process of finding a 3D model, using a slicer software, and then printing it out. So are there any questions that we got? All right, go ahead and stop that. All right, I'm not seeing any. If you can just type it in chat or raise your hand. Meanwhile, I will just work on how can we access the recording. It will be available on the Aurora Public Library YouTube channel. So I'm not quite sure when it will go up there, but yeah, once this presentation is over, you can access it there. You're welcome. All right, so let me go ahead and I will go ahead and share my whole screen. Or actually, I should be able to maybe this. All right, so yeah, I'm just gonna go to thingiverse.com and I misspelled that. So we're going to Thingiverse. And it doesn't really matter what I choose to 3D print. Let's do, these Hanger Ninja Mans look pretty cool. So I'm just gonna go ahead and click on those. And then you go up to download all files. Now, if you want, you can go down here. You can see each individual icon, each individual file that is in this set. So you can go ahead and download all files. And it's just downloading down here. I don't know if you can see that. In the meantime, I'm going to go ahead and open Cura. All right. Let's see, can I get underneath there? Perfect. Technology, gotta love it. Cura is taking a hot minute to show up, so I will switch to sharing my whole screen. So now you should have a better view of what I'm doing. That was weird. There's Cura. Oh, there it is. Perfect. Well, it looks like we are. All right, I don't need that. Sure, it doesn't matter. You can add your own non-network printer. I'm just adding one for the heck of it, just for show. All right, so you can see this is the print bed area. And so this is the size that you would be able to print on. I'm just going to go down here, bring out the files that we have printed, and I'm just going to choose a random one. Nope, that's the wrong button. There we go. All right, so let's just do Ninja Man 2. So you click, drag, and drop. Making a liar out of me. Oh, I need to extract it. My bad. Where'd it go? I don't know where it went, so I'm just going to File, Open Files, and find Hanger Ninja Man. All right, and then open. And it'll drop itself right in my workspace eventually. Where is it? All right, that is taking quite a while to load in. There we go. All right. So, oopsie, good gravy. So yeah, right now he's a little bit big, but we can go ahead and shrink him down. So there's a couple options here. The scale option is right along this left-hand side. So we are just going to, we want uniform scaling, and we can just bring it down to, let's do 25%. All right, that might be a bit small, so let's try 40. All right, that looks good. And we can just drag him onto the surface, and we can take a look. Yeah, and it looks like we got a couple areas like right in here, right here, right here that are red, so they'll need support. Let's go, oopsies, customize our file quality. So the layer height is how much detail you're going to have on your print and how big the layers are going to be, basically. So point 0.1 is pretty thin. 0.2 is standard. So we're just going to go with the standard 0.2 because it doesn't need to be particularly fancy or detailed. It just needs to look cool. And it already does. Then we're going to go to infill. 20% is a little bit much for this, so I'm just going to bring it down to 10%. The grid style is perfectly fine. There's a couple of different filament styles. You can experiment to find what you like, but I find it easier to just go with the basics. All right, so we do want support. All right, and then we want support placement everywhere. And then, yeah, 50% overhang angle is perfectly fine. Build plate adhesion. So let's take a look at our model and see if we think we need, so these blue areas are where it's going to be touching the build plate. So there is enough, oopsies, that's actually going through. All right, so let me show you a fun tip. Is it? No, it is. No, they don't have the lay flat option here. That's a shame. All right. There we go. So we don't quite have anything clipping through the area. All right, so we do see that there's not a lot of not a lot of things touching the build plate. So we will want a brim around what's not touching. So let's go ahead and keep the brim there. And then we don't need to worry about dual extrusion or anything. So we can go ahead and exit out, and then we just press slice. And it might take a little bit depending on how big or how complex the print is, but this is looking quite simple. So this is quite small. This will only take 38 minutes. It'll take 0 grams, so it'd be a very cheap print to use here. And it's only going to take less than 1 meter of filament. And then so what you would do is you just grab a USB drive, and you'd plug it into the computer, and then press save to file. So you can choose to put it on your USB drive and then just plug it into your printer. This saves it as a .g code, which is the file type that 3D printers can recognize. All right, so that is basically how to use the 3D printer. Are there any other questions that we have? Let's stop the share. Then you can go ahead and raise your hand if you're on Zoom or whatever. All right, so if there are no other questions, that is all that I have for you today. Thank you for joining me, and happy printing. Bye.